Okay, so now I introduce you how the equation of the plane. Okay, we have three form, maybe more than three form, four form, how to write equation of a plane. So before we talk about the plane, I remind you that if you have 2 points on the plane, the 2 point define, determine a single line, right? The unique line, right? The same thing in the space here. If you put any 2 point anywhere, you can put a unique plane on this one, right? So let's start with this. Let's give you 3 points. Always you can write equation for the plane with the 3 points, okay? So let's make it the plane like this somewhere. Okay, yeah, the plane. Usually we use the parallelogram to represent the plane, okay? Okay, so because they don't keep going forever, right? I do a little bit different. Look like more three-dimensional. Mean when near to my eye, I make it bigger, and far away, that is shorter. So let's make it P equal 1, 3, 2, and Q equal 3, -1, 6, and R equal 5, 2, and 0. So I have 3 points. You can write equation of plane. So how is it? So first of all, I go for the vector equation of a plane. So we have the vector here. Let's say P, this one Q, and this one R. Okay, this one is R. So remember, each of them represented by a vector. Each of the point represent a vector. This one, if I have X1, Z right here, right? This one Z here, X here, and Y here. So you can connect the point Q from here to here. So that point Q here means the vector 3, -1, and 6. Okay. So each of them is the vector from here. Each of the point is the vector. Now, however, the concept like this. So any point, let's make any point here. Any point here. Let's say the point, any point X, Y, Z. Okay, so now remember, if 3 points define the vector, determine the vector, also determine a plane, then also 2 vectors can determine a plane, right? So 2 vectors look like this, vector go like this, so we have the plane like this. 1, 3 point go like this, so also we have the plane. So now, how to write equation of plane? Any point on the plane here, you can write a combination of this vector and this vector. Okay, but how to find this vector PQ? So vector PQ equal what? Vector PQ equal Q minus P. Okay, so that 3 minus 1 equal 2, minus 1 minus 3 equal minus 4, 6 minus 2 equal minus 1 minus 3 equal minus 4, 6 minus 2 equal 4. That's PQ. How about PR? PR, you take R minus P because you move this one into single vector, right? This one we call the position vector. So 5 minus 1 equal 4, 2 minus 3 equal minus 1, 0 minus 2 equal minus 2. So you have vector PQ and PR. So now any point on the plane here can be written as a combination between this vector and this vector. Okay. Let's say this vector here, half of this vector here, I can do like this, half of PQ. Let make the name of this one. Okay, let make vector Q and vector R, small r, and this one vector P here. Okay. Oh no, the R I reserve for that one. So let's make it this one B, vector C, and vector A. Okay. So any point here we can write as the vector R. Okay. So now, for example, if I have P, half of B, okay, you add with C. So what do you have? Half of B like this. So you go like this, add to C. So you get the vector parallelogram law. So you point right here. Okay. If I get half of B plus half of C, where the point? Half of B and half C like this, So half of C, F with half B using the point like this, and you get the point right here, right? So this, how about minus half of B plus C? So minus half B, you go backward like this, plus C here, this one C here. So you combine two of them, then the point right here. See that? All of the point in the plane, we can write a combination between B and C. So therefore, now this one equation for the graph here. Any point here, I go from here to here. Okay, this one we call R. Okay, vector R. Vector R equal the combination between B and C. Okay, so let's say T times B and lambda times C. If lambda equal half and T also half, I have this point. If lambda equal 1 and T equal 1/2, so I'm going to get this point. Okay, so now vector equation look like this. Vector x, y, z have to equal, you start from here, because this vector here add with this vector here equal this vector R, right? Okay, so now vector R equal the vector A, you add with T times vector B, okay, plus with lambda times vector C, okay, things like that. Okay, in this case, what I have here, vector B equal this, right? So I'm going to have XR equal, we start with vector A here, 1, 3, 2, 1, 3, and 2, add with T times vector B here, is this PQ vector B, so you get 2, -4, and 4, and you add with lambda 4 minus 1 and minus 2. So this one here equation of the plane, where T and lambda we define where the point here is. Okay, the vector R is. Vector R can go like this, like this, like this, like this, anywhere. Okay, now I'll give you a big picture again. So the plane here represented by vector R. Vector R represented by the point x, y, and z. This means this point can be anywhere, and the vector from here to here is a combination between B and C. Okay, some T times B plus lambda times C, they make a combination of two vectors to get all the points all over the plane. If T equal 2, so I'm going to have all the way from here to here, and lambda equal 1, then you have C stay the same, and the point should be somewhere right here. Okay, so that's a combination. So now the form number one is with a vector form. Now number 2, I introduce you, we call the parametric form, right? So since vector R here, the point here is x, y, z, right? So we turn into x, y, z equal that, okay, equal 1, 3, 2, plus T times 2 minus 4, 4 plus lambda times 4 minus 1 minus 2. So now we break into x and y, z separately. X equal 1 plus 2t plus 4 lambda. Y equal 3 minus 4t minus lambda. And z equal 2 plus 4t minus 2 lambda. So this one we call parametric form. Okay, parametric form. Or where T and lambda is, we call a parameter. Okay, so now this is second form of the plane. How about the third one? The third one we call it Cartesian form. Cartesian form is related between x and y and z only. So therefore we have to eliminate this. Okay, we have to eliminate the parameter t and lambda. So let me copy this again. You have x equal 1 plus 2t plus 4 lambda, and y equal 3 minus 4t minus lambda, and z equal 2 plus 4t minus 2 lambda. Look like I want to get rid of t. First thing look easy, right? If you add equation 2 and equation 3, so you add 2 plus 3. Okay, equation 2 plus 3, what you have here? Y plus z. Okay, you have equal y plus z. Now 3 plus 2 equal 5. Equal 5. This plus is gone. Z is gone. So negative lambda plus negative 3 lambda equal negative 4 lambda. So this one the first equation we have. Now we want to get up to you multiply the first one by 2. Okay, the reason is 2 times 2t equal 40. You add this one, t is also gone, right? So we multiply 2 times equation 1. You add with equation 2 to get rid of t. So 2 times x plus y. 2x plus y equal 2 times 1 equal 2 plus 3 equal 5. 2 times 2 equal 40 minus plus it minus 40 is 0. 2 times 4 lambda equal 8. 8 minus 1 equal 7 lambda. Now all you need to do is to get rid of lambda, right? So you have two equations here. So you solve for lambda right here. So 2 plus 3 become equation A. So y plus z minus 5 equal minus 4 lambda. Therefore lambda equal y plus z minus 5 divided by minus 4. So this on a lambda for A equal. However, B here, equation B here become what? Become 2x plus y. 2x plus y minus 5 divided by 7 also equal lambda. Okay, so now that means this one have to be equal to 1 because both of them equal lambda, right? So by this way we can eliminate lambda, right? And we can say this one equal that one. So let's erase this. So I put this one next to this, okay, equal. So I have 2x plus y minus 5 over 7 equal this. Now how to simplify this? This one here we call the Cartesian form. Relate between x, y, and z also. So how to get rid of this one here? So I have negative 4 2y plus 2x plus y equal 5. 8 minus 7. So this one here you have y plus z equal 5 minus it is 2 3 equal 2. This one 2. So this one minus 3. Okay, so I don't want to write this minus 3. Okay, so not minus 4. So minus 3 here. Okay, so divide by minus 3. Okay, Mr. Don't worry. I don't want to go. This okay. So now how to simplify this? Multiply by 21, right? Negative 21 or 29 doesn't matter. So you multiply 21. Okay, 21 divided by minus 3 equal minus 7, right? So become minus 7 times y equal minus 7y, minus 7 times z equal minus 7z, minus 7 times minus 5 equal plus 35. To the right side, 21 divided by 7 equal 3. 3 times 2 equals 6x. 3 times y equal 3y. 3 times minus 5 equal minus 15. Finally, I put x in one side, so I have 6x plus 7y move there, 10y, and plus 7z, okay, 7z equal 50. 15 plus equal 50. So this one here is equation of the vector R given 3 point P, Q, and R. There are 3 of them. One of them is vector form, second of them parametric form, and lastly this one is the Cartesian form. So now you look at this. I want to remind you. If you have x plus y equal 8, so this one represent the line, right? But if you have x plus y plus z equal 8, doesn't mean the line in a 3 dimension, doesn't mean so. So this one equation of the plane. X, Y, Z equals some number. Okay, so I remind you that. So if you want to graph it on that is, you can do this way. You can do this way. X and Y and Z. Okay, so if you let Y 1x equals 0, that means you talk about this one 0, right? So Z equals 8, so I get 1, 2, 3, 4, 5, 6, 7, 8. So the point here should be 0, 0, and 8. If you let Z and Y, which is this plane here, equals 0, 0, Y, 0, so X equals 8, 1, 2, 3, 4, 5, 6, 7, 8, and so on. And finally, if you have X and Z equals 0, Y have to be 8, 1, 2, 3, 4, 5, 6, 7. So now the plane here is, the plane goes through 3 points like this, okay? Through 3 points, look like, it's plane forever. Okay, so this is the equation of plane, not equation of a line, 3-dimensional line. Okay, so still you have only this one here. If you have 2 of them, variable is the line, and 3 variable is the plane.